Oh, I would love that. I mean, he seems like a fine young man. I'd love to get together with him. We'll have a live stream, so nobody's going to edit that. And I mean, we could do it many different ways. If he doesn't want to travel, he could sit where he is. I could sit where I am, and we'll have just a discussion. It doesn't even have to be a debate if he doesn't want. Just a discussion about these topics. I mean, we can go through each slide on his video and discuss that, or each slide on my video and discuss that, or however he wants to work it. I'd love to do it, but I got something even better. We can do something here at the university. I'll get a lecture hall, and he and I can be in there. We can be distanced. We can be 12 feet apart. We'll each have a podium. We'll have a film crew there. We can do it like that. We can have some people in the audience that are dispersed in the audience. I will pay. I will pay to have him fly to Houston I'll buy his ticket to Houston, and I'll put him up either at a hotel, or if he wants, he can stay in my home. We have a guest room. He can have dinner with me and my wife and my family, and tell us all about himself, and we can discuss origin of life or any other topic as he'd like. I'll be glad to do that. If he wants to have me fly to his city, I'll pay to fly to his city, and I'll pay to stay in a hotel there and do it in his city. So absolutely, let's do that. That's I'd be glad to do it.
Wow, folks. So you just heard it from Dr. James Tour. He is offering to either pay for Dave Farina to fly to Houston. He will handle all the scheduling, set up a debate in one of the lecture halls there, hire a film crew to come and put it all together. Or if Dave doesn't want to fly to Houston, Dr. Tour will go to him. I think he's out in LA. Will fly out there, put himself up, and have a conversation there. Or if he doesn't want to do any of that, correct me if I'm wrong, Dr. Tour, you're saying you'd be more than willing to just do a live stream if he wanted to go that route versus a face-to-face interaction. Is that a kind of a fair summation of what you're offering to Dave Farina?
Absolutely. And with those film crews, we could live stream that as well if he's worried about anybody doing any selective editing. So we could live stream any one of those venues just to make sure that there's no selective editing. And I'd be glad to do that with Dave. I mean, like I said, he seems like a fine young man. He's trying to teach the masses. Let's get any science corrected that needs to be corrected. Let's do it.
That's awesome. Well, folks, you just heard the words directly from Dr. Tour's mouth. So let's see what happens, and I'll keep you up to date on whether or not Professor Dave will accept the offer from Dr. Tour.
I'm James Tour, and I still approve this message.
Dr. Tour, thank you so much, sir. How are you this lovely Friday? Thank you so much for taking the time to come on and have a little fun with that and back up your claim. How are you, sir?
Good, thank you. Thank you for having me on, John.
Yeah, it was just kind of a last-minute request for you, and we're looking at some other ways to substantiate that video. I mean, as I was telling the audience, I mean, we recorded this 2.5 weeks ago. There's been very fascinating, all of these folks who've been attacking you, attacking me, claiming that we're making it up. It's false. You didn't actually mean this. You're doing this in response to his latest videos, all these kind of things, and that you wouldn't actually back it up. So I thought, what better way to substantiate this than to invite you on and see if you'd still continue with that personal message. And I know there were some other things that you wanted to say about this exact topic, and the floor is yours, sir.
So I'm glad to meet with Dave anytime. And like I said, my offer stands. I'll fly you to Houston. We can get an auditorium on the campus. We'll get some spectators there. And if you're worried about social distancing, which I guess we don't have to be worried about it anymore because of the new regulations. But if you're worried about that, we can have things distanced. We'll live stream it so there's no editing. But, John, this is a way for me just to walk in obedience to my Lord Jesus, which I really love to do because, I love Jesus more than anything. And Jesus says, turn the other cheek, walk the extra mile, bless those who curse me, and pray for them. And this is an opportunity for me to walk in that. And so I'm just doing what Jesus would have me do. And I'd love to do this. And though he's welcome to stay in my home. We have a garage apartment guest room. It has its own entrance. It has a little kitchen in there, its own bathroom in there. And he's welcome to stay with us, have dinner with me and my family if he'd like. We can have a few other students for dinner. If he's worried about coming in the house because of COVID, we can put some tables outside, put a table outside and do it. So I'm glad to do it. And I thank you, John, for having this interview with me and just giving me a chance to talk about it and to answer the many questions that were asked of me concerning my videos under the different videos. So I got a chance to go through a lot of that. So I appreciate it.
Oh, it was great. It was a significant honor, Dr. Tour. I really appreciate you spending the time with me. I tell people, I spent 6.5 hours together that Monday, and went into a lot of different aspects, different topics, different facets of your series. And I think folks, as I unveil different stages of this, tonight we're going to get into kind of basically the first 50 minutes of the initial conversation that Dr. Tour and I had. But then after that, we've got a whole nother hour of conversation. We dive into much more detail. And then we've got almost 4 hours of Dr. Tour responding to individual comments, one after another, and all sorts of different kind of topics, if you will. And I think people really don't appreciate, and you will after you watch this this first portion of the interview. I don't think people really appreciate the value of Dr. Tour's time, all the things he's involved in, and the fact that he has taken the time to address this issue regarding our very existence, and what is the underlying necessities that must be accounted for, what's being glossed over. And so, Dr. I really appreciate it, and I know that you've been an inspiration to a lot of people. And as in my pre-show, and I know in the post after show, the PhD chemists that I'm going to be talking with, they've relayed to me that they were very inspired by you being willing to take the risk, go out and do this thing. And they wanted me to relay to you that they're praying for you and that they have your back from a scientific perspective on all these things that you're addressing.
Well, I appreciate that, John. And there's been so many chemists, scientists from around the world that have contacted me that have told me something similar to that. So I really do appreciate your prayers, and I appreciate your willingness to also take a stand, especially these gentlemen that are joining you today, to take that stand openly and to talk about the science. So thank you.
Awesome. Well, Dr. Tour, thank you so much for your time. I really appreciate it. I know you're going to be listening in. So thank you again. Hope you have a great weekend, and God bless. And we'll get on to the fun stuff, Dr. Tour. Appreciate you very much.
Bye-bye.
All right. Okay, ladies and gentlemen, so you have heard it directly from Dr. Tour for the second time. So for everybody in the audience, for all of those followers of Dave Farina who have been going on ad nauseum about how this is not actually legitimate, you have once again heard that it is, and that Dr. Tour will back up his offer, and there is no shenanigans, there's no chicanery. It is absolutely 100% legitimate. And it is, available to be had if Dave wants to accept the offer from Dr. Tour about, having that face-to-face conversation that is a rarity and something that is worth a tremendous amount of value just from a time perspective. But enough from me, ladies and gentlemen. It is now time for us to get into what you all came for. And that is part one of my epic interview with Dr. James Tour. And assuming I can figure out where I put this, there it is. We can get going, ladies and gentlemen. Without further ado, part one of my interview with Dr. James Tour. Hello and welcome to a special event here on Logical, Plausible, Probable. I'm your host, John Maddox, and today I have the incredible privilege of interviewing Dr. James Tour, someone I have admired for quite some time, an individual of astonishing success in the world of synthetic chemistry and nanotechnology, and even more importantly, a man who has had the courage to publicly challenge the status quo on a variety of fronts, regardless of the personal and professional attacks that this has brought upon him. It's kind of amazing, to be honest. The main focus of this interview will be a follow-up to Dr. Tour's amazing 13-episode lecture series on abiogenesis and the origin of life. And we'll be going into a great amount of detail in response to a variety of questions and comments raised by fans, critics, fellow scientists, and even some true haters of the good doctor. I've had the opportunity to watch all of these videos several times, actually, for several of them. And I strongly recommend you take the time out of your day to do so yourself, because as many people are who are taking the time to do it, you will quickly realize one of the most qualified chemists on the planet has taken time out to explain things to the rest of us. And the value of that is just truly astounding. Now, in just a moment, I will be doing a brief overview of the incredible discoveries and professional credentials Dr. Tour has earned in his distinguished career. But before we get to that, Dr. Tour, welcome to the stream. Thank you so much for taking the time to share your knowledge with the rest of us.
Thank you, John. I'm happy to be here, and consider this the postscript to the series on abiogenesis.
Well, it should be pretty fun. There's a lot of content. Obviously, we're not going to be able to remotely cover the details, which is why obviously you put the incredible amount of time into the structure of it and the research. But before we kind of move into the substance while we're having the conversation, I wanted to put to rest some of the, in my opinion, honestly, quite laughable attacks on your personal credibility. It's honestly kind of entertaining. You and I were talking before we got on here about how I came across, learned about you well before you got involved in all of this, and I just wanted to kind of relay to the audience and to the haters some of your accomplishments and focuses in research that they might want to be aware of, where they start running around and saying that you don't know what you're talking about. Now, Dr. Tour's work on carbon materials chemistry is broad and encompasses furline purification composites, conductive inks for RFID tags, carbon nanoreporters for identifying oil downhill. That's amazing. Graphene synthesis from cookies and insects. Amazing. Graphitic electronic devices, carbon particle drug delivery for treatment of traumatic brain injury, the merging of 2D graphene with 1D nanotubes to make a conjoined hybrid material, a new graphene nanotube 2D material called rebar graphene, graphene quantum dots from coal, gas barrier composites, graphene nanoribbon de-icing films, supercapacitors and battery device structures, and water splitting to H2O and O2 using metal, I don't even know how to pronounce this word, chalcogenides?
Chalcogenides.
Oh man, I'm glad that the PhD also had a hard time pronouncing it. Otherwise, I would have felt bad there. Now, his work in the synthesis of graphene oxide, its mechanism formation, and its use in capturing radionuclides from water is extensive. And Dr. Tour has developed oxide-based electronic memories that can also be transparent and built onto flexible substrates. And more recently, he has been using porous metal structures to make renewable energy devices, including batteries and supercapacitors, as well as electronic memories. And one of the things that maybe we'll talk about later on is he's very well known for his work on nanocars. Actually won, I believe it was the first contest in this back in 2016, I think it was. They won the nanocar race, which is pretty amazing. Single molecule vehicles with 4 independently rotating wheels, axes, and light activated motors. Folks, it ran on photons. It's pretty amazing. And Dr. Tour was the first to show that Faringa-based motors can be used to move a molecule on a surface using light as opposed to electric current from an STM tip. Now, all of this has resulted in quite a few different awards, shall we say. He's been inducted into the National Academy of Inventors. He's one of the 50 most influential scientists in the world. Scientist of the Year. I mean, you just look at this list. I'm not doing this just, fluff up the good doctor, but he's earned all of these incredible awards, and I could even list them all. I didn't want to have a bunch of slides here. And all of this has turned into over 700 publications, over 115,000 citations, 45,000 of which are just in the past 5 years. The doctor has over 150 patent families. That's not just individual patents. We're talking about groups of patents. And on top of that, in the past 6 years, you have founded 14 companies and had 2 of them go public, I believe. And enough of my long-winded diatribe. Honestly, doctor, for somebody like myself who's been involved in the world of startups, just that last piece about 14 companies and not 1, but 2 IPOs just blows my mind. All this while leading up to research in new technologies has with graphene that has the potential to utterly revolutionize a plethora of industries. Can you give us a little insight into how you have managed to pack so much into such a short period of time?
Well, John, I don't know precisely, but I can tell you the grace of God. It's the grace of God. I believe Jesus Christ is the Son of God, and it's His grace that's showered in upon me. And I'm thankful to the many students that I have that are working busily in the lab. And but I look back over these 32 years, almost 33 years of being a professor, and it's far more than I thought I'd ever do, and I just have to give thanks to God.
Well, we it really is amazing. I think the more, and you understanding the fundamentals better than I and the majority of the world, I'm sure the significance and the awe and the magnitude of what is necessary for our existence probably strikes you even more than the average person who goes throughout the day not knowing all these underlying necessities for our existence. You ever contemplate that? I know for myself, as I started learning
Yeah.
about these things, just walking down the street, looking at the leaves, and
Yes.
realizing I'm watching the most amazing solar technology of all time. Blows
It
my
is
mind.
utterly amazing. I mean, and for people to suggest that we would know how to pull something like this off is just crazy. I mean, you talk about a leaf. A leaf has got a funnel. It funnels photons of light from the sun into the middle of a porphyrin where there's sitting a magnesium atom. And that photon hits that magnesium atom and starts a chain of electron transfers that then are going hundreds of angstroms down these chiral tunnels to start this photosynthesis process so that tree can build itself and convert carbon dioxide into the carbon that it needs to build that tree. This is utterly amazing. And for people to suggest that we understand the origin of life and these things are figured out and all it just takes is a few million years or a few billion years, and that's why I did that whole series. I had to explain the intricacies of organic chemistry and what we're up against here, because the common person just doesn't know it. It's just amazing. And so that's why I took the time to go through that series, which took a long time. But I had to explain really the details of what's going on, because when you get down into the details, it's a whole different ballgame.
Yeah, I was reading a book on quantum biology a couple years ago, and they were discussing the quantum coherence, controlled quantum coherence state in photosynthesis that's necessary to reduce, basically have no energy loss when those it's being transferred down those pathways you were referring to, and how so many of the physicists claimed, well, that can't be possible because there's no way that could happen in a wet, warm environment. And then when somebody finally decided to go look, they realized that, oh wait, that actually is the case. And to me, when you really start to contemplate these things, the necessity of experts such as yourself really kind of outlining the nuts and bolts and the bare bones. Like, you weren't even in the lecture series, as people will find out if they go and watch it. You weren't even getting into the complexities that are necessary in a biological system further up the food chain. You were
No,
talking about the nuts and bolts.
I was just staying on the pre-biology level, and I was talking about what needs to be done, and it's just staggering. You get up into the biological level, and this whole series, this video that I did on chiral-induced spin selectivity. I mean, when you match the spin of an electron to the chiral structure of the pathway that it's going through, then you get this enormous transfer with very, very little energy loss. This is how it's done. I mean, we didn't even know this until a few years ago. And there's so many other things that we're going to learn that we have yet to learn about the complexity of a living system. And so to say that we've got a cell, even a single cell, figured out is just I had to have people see from my perspective.
Quick question about that. While I have you, with the chiral-induced spin selectivity, you had mentioned, I forget where it was. You had talked about, oh, this concept hadn't even been considered until about 20 years ago. So I was doing some searching, and I don't doubt for a second that it was around that time frame that the premise was first put forth. But I wasn't able to really find any publications on it. And the earliest one I think I found was like 2012. And then I've seen a bunch that popped up in the last like 3 or 4 years, most of them from like 2018 on. So is it kind of one of those, this might be in the, say 15, 20 years ago, is it kind of a, hey, this might be what's happening sort of thing, and it's taken until now for there to be real like substance to the discovery?
Yes, it was probably about 20 years ago when it was conceived, and about 10 years ago when people really started, just a couple of people really started researching this, and now it's getting a lot more traction, because what it would allow us to do if we could capitalize on this is really increase the yields of our organic reactions. And this explains why biological systems can do things with the very, very high yields that they get. We were trying to do this all with sterics and van der Waals interactions. This is the fitting of molecules together, without realizing what was happening where we had to where we could align the spin with a certain chiral environment. Just beginning to learn about this, but people are taking note. Yeah, this is brand new. I'm telling you, very few chemists even know this, and like zero biologists know about this. And that video probably enlightened a lot of people. A lot of scientists wrote to me that, wow, we didn't even know about this. That's the beauty of YouTube, because scientists have a lot of other things to read. So people publish papers, they don't generally read it. But you get it out on a YouTube video and they're like, wow, I got to look into that a little bit more.
Well, I mean, the significance of it obviously has, I mean, I would assume your peers, at least chemists, probably, once you told them about it and the fundamental properties of it, I'm assuming that their expertise probably enabled them to extrapolate out the potential very rapidly in their own minds. They're like, oh my goodness, this could be a potential game changer. Is that a fair assessment?
Yes. The organic chemists are like, whoa, we had no idea. That's how this thing is pulled off in living systems. That's how it's done. And this is an awakening to them.
Now, I know later on I'm planning on asking you some more questions, and we're going to address some comments from folks about the chirality issues and such. But I was just blown away that even after you talked about, you had your episode on the homochirality problem, just from a fundamental chemistry perspective. Then you talked about chiral-induced spin selectivity and its significance. And then I had, just to say, people focused in biology interact with me personally, claiming that the chirality problem, A, was solved and B, wasn't that big of a deal in the first place. And that, oh, we could have, racemic mixtures and all this kind of stuff. It's no big deal. That can be solved later. And I'm just, what's your response to that? Just on a surface level, what's your kind of response to that? Is that somebody's living in kind of a uninformed state? They're in denial? Like, what would your initial reaction be if somebody told you, which I'm sure you've been told this many times, but somebody just said, hey, it's not that big a deal. What would you respond? How would you respond to that?
I tell them they're wrong. They're just wrong. They know very little about the alignments that are necessary for so many of these templating reactions, when it goes from DNA to RNA and RNA to the structural proteins. You can't do this with racemic mixtures. These have got to be homochiral compounds all along the way. And then when you put on top of that the requirements of the energy involved, you've got to have it. And that's what I talked about in the chiral-induced spin selectivity. So I think if they just watch the chiral-induced spin selectivity video, they begin to see that they're real rookies.
No, that makes sense for sure. Now, one of the things you talked about, I think it was in episode 3 or 4. You talked about the hype problem that's been going on in the OOL research community, maybe in the papers, but definitely by the media. And you kind of talked about how it's time for hey, folks, we need to have a gut check on this whole thing. So, but you've known this for a while. So what was it that really inspired you to say, okay, kind of to quote good old Jean-Luc Picard in one of the old movies, this far, no farther, the line must be drawn here. You had to step away from and focus a lot of time on putting all this together. So what was the kind of the catalyst that finally put the pedal to the metal?
Yeah, I mean, that's an interesting story. Why did I even enter this fray? I mean, why do it? I work on a lot of other things. I didn't have to work on Origin of Life, and I had started seeing some talks related to Origin of Life, and somebody challenged me to write an article of the things that really bothered me about this. And so to write an article on it, which I did for the journal Inference, and you have to read some papers. And as I read the papers, I was utterly shocked at how little we really know about life's origin and the experiments that were done. So few people can get into the details of an experiment. Because you really need to be trained as a chemist to read the supplemental. And when I went back to the supplemental procedures, the things that are published only online, the things that you have to click on, you have to have subscriptions to these journals to get into them, you see that all the problems that are there in these syntheses, and how this would never work on an early Earth. So then it became easy to write papers and expose this. And then I'd read the comments that the authors themselves would make in their extrapolations of what they said they could do. And I'm not talking about really good synthetic chemists, not just the things that they were quoted in saying to the press, but the things actually in their research articles that the editors let them put in there, that the reviewers let them put in there. So you know, and then I exposed it, and people started doubting me, and so I exposed more, and people started, so I exposed more, and finally, to the point where it hit YouTube, and then I had to do a YouTube rebuttal because of people saying that I got this all wrong. So anyway, you had just shown one of these articles that I wrote for the journal Inference, and that was one of the articles that I did. So if you just Google James Tour Inference, it is a free online journal, and I think I've written about 5 articles on origin of life. There's one more coming out very soon where I'm critiquing a particular article that came out in December, and just showing some of the things that these researchers actually say, and then exposing that. Yeah, and so there's some of the articles that they've written on origin of life, and then I think a 5th one is coming out very soon.
I think there's actually one. I think you already have 5. This
Okay.
when I screenshotted this, there was the one I was reading, and then these were more by the author at the bottom. I think you have 5 already.
Okay.
And folks, I'll put a link to these in the description of the video. And I have personally read these, folks, and Dr. Tour does a great job of talking at a high level as well as dumbing it down for the rest of us to be able to understand like the real problems. He's both calling it out from a scientific perspective and then being like, hey, here's why this doesn't make any sense. And I read your first one was in what, 2016, I believe. Was your first one. I've read those, and it's pretty interesting to me reading through those, especially now that I've become much more involved in the YouTube debate environment over a lot of these topics. I've been fascinated to hear talking points from people who are in favor of all these things that I know beyond doubt you have annihilated just in those articles. And then simultaneously, I hear from folks that, well, Dr. Tour has never published an article in Origin of Life research, therefore, he doesn't know what he's talking about. And I get so much entertainment over it because I'm like, well, obviously you haven't used Google. It takes about 30 seconds to find this. It'll take you longer to read it and way longer to understand it. But you can find things that you have addressed going back then. And now people are, especially now with your video series, people are acting like this is your first time in the ring, and that you've never actually looked at this on anything other than the surface level. Have you been getting that same kind of jab sent to you?
Well, from the beginning, I mean, people say, well, you know, most of the people who say this are the untrained. It's not the trained that say this. It's not the trained people that question my ability to read the papers in Origin of Life and critique them. Because they know as a synthetic chemist, I can look at the experimentals and understand them. So it's generally the untrained that will say, oh, well, you haven't published in Origin of Life. Now, to be fair, that journal Inference, although there is a very strong editorial board, it is not peer reviewed, meaning that it is not reviewed by it is not sent out to Origin of Life researchers to do critiques on it. And so there's several things on that. Number one, when you are coming against an entire area, like I am, talking about the fallacies that are put forth, it's not easy to get that through the people that work in that very area. That's what you have to do to get it through the quote unquote peers. They have to say, yeah, this is worth publishing. It's number one. Number two, I'm quite able to critique these sorts of things because I'm asked to critique things all the time in areas that I haven't specifically worked in. That's what we do.
Quick interjection on that, Dr. Tour. If I'm correct, you have been a reviewer for formal journals in your career. Is that correct?
That is like saying, John, you have you have consumed water in your lifetime. Is that not correct? I mean, I get probably, because I've published a lot, I get probably 10 requests from editors a day to review articles for their journals, and I have to turn down most of them, or I wouldn't have a life. And
so would this kind of be like an analogy I kind of draw from this is like the athlete or the up and coming athlete telling the multiple gold medal winning person who's now the judge that they don't understand how XYZ works. Is that kind of a fair?
Yeah, that'd be a fair assessment. So, but my point is, we're asked to review things on papers that we may not have worked in that specific area, but they know that we're able to critique the science there. So in other words, if a person has not run, this is probably for the trained chemist, if a person has not run a palladium catalyzed cross-coupling reaction, does that mean you cannot evaluate a synthesis that involves a palladium catalyzed cross-coupling reaction? Certainly you can. If you've never made a saccharide and run an NMR, would that mean that you can't assess the NMR of a saccharide? Of course not. We review papers generally. I teach from a textbook. I've taught from undergraduate textbooks for over 30 years. And there's hundreds and hundreds of reactions in there, many of which I've never run. But I can teach the reactions because they make chemical sense, and I can teach how they work. This is how we do it. The good thing about it is that I don't work in the origin of life, so I have no horse in this race. It's not going to affect my funding directly. You think people who work in the area of origin of life can say negative things about the area of origin of life and still expect their colleagues to approve their proposals to get funded? The other thing that happens is that papers have been written that are critical of current origin of life, and I cited one of those in the series, the paper by Clemens Reichert, 2018 paper in Nature Communications. He says, you have this purity problem. You can't do reactions unless you have purity. He says you have this other problem where you have you put all this experimental input into it. You have experimenters doing this. You have to pull that out in order for this to be prebiotically relevant. Well, that was published in 2018. What about all the papers that have been published for the last 2.5 years since that paper? Do you think they read that paper and then they said, oh, well, Clemens Reichert really exposed this, I can't publish my paper? No, they just do it anyway. They just do it anyway. They just look at what's been written in the literature and they ignore it. They just go ahead and continue doing what they're doing.
And one of the few chemists that I'm aware of on the planet who has more citations than you is George Whitesides, I believe. Mm-hmm. He also wrote a review on the topic with a very similar assessment of.
I know George. In fact, I did a sabbatical in his lab in 1994. He's a friend of mine. George is a good bit older than me, but yes, he's an amazing chemist, and he's not afraid to say there's real problems in origin of life that we have no idea about. And people would say, well, you're not brave enough to publish a peer-reviewed article on that. Bravery? Are you kidding me? I publish peer-reviewed articles every time. I publish about 25 to 30 peer-reviewed articles every year. How many people do you know that do that? It is
that's more than most do in their career, is it not?
Yeah, it's more than some do in their careers, certainly. And the thing is that it takes a lot more to put something out on YouTube, because now you open yourself up to all sorts of things. It's not just the expert that is evaluating it; it is the non-expert is criticizing you. And the thing is, if you publish a paper as a peer-reviewed journal, if somebody contests with that, sometimes there'll be one round where people could write a letter in. It goes through an editor. It goes through a review board. There's no bad language. There's no personal attacks. It just deals with the science. When you open yourself up on YouTube, there's foul language. There's personal attacks, which was like half of the video that was made about this origin of life that talked about my stand on this was a personal attack on me. I mean, it takes a lot more bravery to put this out on YouTube. And it's a new medium, because when I put it out on YouTube, people can't just ignore this. You don't read many people don't read the primary literature. So they don't know about this Clemens Reichert paper from 2018 that he was calling them out. And the Origin of Life researchers just ignore that. Do you think they cite Clemens Reichert's paper saying, yeah, we did have a lot of input here, of chemist input. Yeah, we did use pure things. And Clemens Reichert said that this is not characteristic of Origin of. No, they just don't cite his paper. Now, I put it out on YouTube. It gets a whole different medium. And there's more people that have seen my series in this 1 month, than any of my papers ever read combined. Well, not combined, but certainly my most highly cited paper in my career might have 10,000 citations. I can get 10,000 views very quickly on YouTube.
Mm-hmm.
So this is a new medium for getting it out. And so anyway, that's kind of my response to that.
No, I totally follow you. It's kind of interesting. The couple 3 or 4 days ago, actually, I had a interaction with an academic, we'll just say that, who we were going back and forth on some of the different points in relation to abiogenesis. And I was like, some of the things they were saying directly contradicted different things that you had outlined and detailed and showcased why this was relevant, et cetera, et cetera. And I'm like, have you watched Dr. Tour's series? And they said, oh, I watched like 2 episodes, but I don't need to watch the rest of them because all he's going to say is, oh, you can't do this unless you go buy the chemicals. And I just started cracking up. And this is an academic, okay? Mm-hmm. With the letters after their name, shall we say. Mm-hmm. And I'm just like, if that's what you think was the point that Dr. Tour's making in that lecture series was, oh, we can't do this unless you buy chemicals, therefore the rest of this has, no relevance. I have to question your knowledge, or more importantly, come to the conclusion that you're in a state of desperation to avoid the point that you're making being accepted because, as you were pointing out, dramatically threatens their funding. And as somebody who's been involved in cap raising in the business world, there's no way you're going to go in front of your board or the investment group you're trying to raise capital from and be like, hey, so I know I've been telling you that I'm really getting close to this, but it turns out I don't have a viable product. I don't actually think I can take it to market. Yeah, and I'm really not seeing how this could possibly be worth your investment. I mean, you get laughed out of the room for even having, walking in the first place, right? And if not being significantly questioned for how did you justify the first round of investment? So, I mean, I understand where they're coming from on not wanting to, publicly say this, but at the same time, if you're going to operate from this, oh, I'm a very high level, academic researcher, don't question me. Somehow these things kind of have to be, put to the public, like what you're doing right now. And more power to you, sir. It's much needed thing.
No, and you're absolutely right. I mean, even researchers who are supposed to be commenting with a critique have accused me of saying, well, Tour just says we don't know, so therefore it must be a miracle on how it happened. I mean, where on earth did I say that? I've never claimed anything like that. So obviously they haven't watched the series, yet they're beginning to critique it. Look, the reason I have to do this, and the reason I have to call this out, it's not that I've not been willing to engage with my colleagues on Origin of Life. A lot of credit to Lee Cronin, where he got on that unbelievable podcast, and he and I were able to have a conversation. He is the first Origin of Life researcher that would have a conversation with me. There was a time just about a year ago, maybe it was probably a year before COVID, so 2 years ago, that a third party invited a lot of top researchers in Origin of Life to get together with me. And they were going to pay our way to anywhere in the world that we wanted to be. We could have been in France, in Nice, we could have been in Italy, we could have been in London, anywhere. And they would fly us all out business class and have a conversation. And there was going to be a Nobel Prize winner that was going to be moderating and to say, what are the key things we have to do to begin to move this field of Origin of Life along? And of all the people that were invited, nobody accepted the invitation. Some commented, well, Tour's religion influences him too much. It's not worth doing this. Another one commented, well, I would go, but I do not want to be asked to defend anything that I've written. I mean, so really odd things, but nobody would come together and talk with me. So I have to use this venue. This is the venue that I have to use, and let them watch the series and start calling it out. But they better watch the series, because if they come with something that they say, well, Tour says this, I'm going to call them on it. And I'll go to their video and I'll say, okay, you said this. You're going to have to show me where I said this. Where did I say this? And how did you address this? And where do you claim? And that video was based on what was known to that date. If you have new papers coming out, all right, well, I can critique those new papers coming out, but you can't ask me to critique things that aren't yet in the literature. I was critiquing based on what I knew from that time period up until a few months ago in Origin of Life research. So anyway, this is probably going to occupy me for the rest of my life.
Well, they hopefully won't keep you from any new amazing paradigm shifting invention. So let's we're going to be talking about this portion of the topic quite a bit here in the rest of our discussion. So let's shift things over real quick before we get back into that. And I would love to hear you expand a little bit about your recent presentation to Congress on the potential paradigm shift that is now actually a feasible possibility in relation to the graphene production or generation process that has been developed in your lab. Can you kind of explain to the audience first what graphene is, and then why we're potentially standing on the edge of another industrial, technological, and just a whole new revolution?
Yeah, this is graphene is single sheets of graphite. It looks like a sheet of graphene looks like chicken wire at the atomic scale, where each one of those vertices in the hexagon of this chicken wire are carbon. And it's a sheet of that. It's a very strong two-dimensional material. As a two-dimensional material, meaning it's just sheet, it's not three-dimensional. And as a sheet-like structure, it's the strongest sheet-like structure you can come up with, because the carbon-carbon bond is one of the strongest bonds in the universe. And it's not a single carbon-carbon bond. It's a bond order of about 1.3 between every, meaning that's you take the carbon-carbon bond strength, which is about 85, 90 kilocalories per mole, and you multiply that times 1.3, and the whole thing is made out of that. And it's super strong. It's conductive like a metal, and yet it has the light weight of something that's carbon, like a piece of plastic, lightweight, but conductive like a metal. It can strengthen materials. It can be used to strengthen concrete. It can be used to, you put a little bit in asphalt, it increases the lifetime of the road by 3x. These are huge energy savings. You could use 1/3 less concrete. Concrete is 8% of all CO2 emissions in the world. So you can really lower CO2 emissions. And it's a nice terminal carbon sink. It's so slow to re-enter the carbon dioxide cycle because microbes don't eat it up generally very easily, because we have graphite in the world, which is just the agglomerates of graphene sheets stuck together. So it's a way of a sink for carbon to keep it out of the CO2 environment. Now, the process that we developed for this is it's just amazing. It is so much fun to be sitting here and talking about this. This is graphene is amazing. So right now,
Dr. Real quick, I know you might be about to do this. I was about to ask you to do the kind of break down how it used to be ridiculously expensive, and then
yeah. I'm getting to that. So
sorry,
graphene used to cost. Graphene right now costs $60,000 to $200,000 per ton, and about 10 tons a year are made, and it's all bought. If you own a Ford motor vehicle, there's graphene in that motor vehicle. There's graphene in the foam rubber seats. There's graphene in the underhood insulation, and they'll put more graphene in it if it were cheaper. This process, we can take coal. We can take coal, which is $100 a ton, and in 10 milliseconds convert that coal into graphene, and take something $100 a ton and go to something that's at least $60,000 a ton. I mean, think about those economics. And the amount of electricity that we put into it is about $35 per ton. I mean, these are just staggering numbers. Not only that, we can take plastic waste. Plastic waste is a huge problem on this planet. We can take plastic waste that's made out of carbon predominantly. We convert that into graphene. We can take any source of carbon, waste food. Waste food is really bad. 30 to 40% of all food is thrown out in the world, not just in the US, but worldwide, because it goes bad. If you eat it, you'll die. It'll make you sick. And so when that hits a landfill, it forms not just CO2, it also forms methane, which is a much worse greenhouse gas. We can convert waste food into graphene. I mean, household waste. When you throw stuff out in your house, most of what you throw out is carbon-based. If it's not a hunk of metal, and if it's not a rock, it's carbon. Household waste, we can turn that into graphene, and then it doesn't enter the CO2 cycle again. It's a naturally occurring compound. You can make bone composites out of this stuff. It's non-toxic, it's lightweight, it's conductive. So that's going to be a huge process. The company is Universal Matter, and I don't know if you don't want me to make plugs for this, but if you went to the universalmatter.com, universalmatter.com, that website, there's a little movie on there, in there, a 3-minute video. You can click on that and you can see about this process. And that company is just rocking and rolling. It is just moving along so swiftly. Everybody wants to invest in that because they see the potential. So it's really exciting. We have other processes where we have another way to make graphene from any surface, and lasers. This is not bulk production, but this is pattern production for electronics. It's called laser-induced graphene, and the company on that is LIGC, for laser-induced graphene, LIGC, and Applications Tech, and that is coming out with air filters that give occasional heat cycles to destroy anything that's on them. So you talk about bacteria, you talk about viruses, you talk about in hospitals. I mean, it's going to be great. So that's taken off with graphene, and so we've got just so much transitioning from our academic lab and going into the industry. That's the hard part. How do you take something from a nano lab where you do it on a tiny, tiny bit and scale this up to tons of stuff? And so, you know, that's part of that valley of death that you've got to get through. Do you want more, or is that it?
I mean, no, I mean, that's extraordinarily fascinating. I mean, it's in your conversation with and by the way, folks, there's a video on Dr. Tour's channel with his presentation to Congress. And this was, I think, 2.5 weeks ago, maybe.
Yeah.
And it was actually kind of fascinating to listen to there were multiple people involved with it in the presentation. And it was pretty funny. The members of Congress kept going back, so Dr. Tour. And then somebody else would say that, so Dr. Tour. They were very interested in one of the things I found very interesting that you were bringing up was the necessity, you kind of alluded to this a minute ago, was the necessity of having a bridge between the lab and industry to be able to take these potentially revolutionary discoveries and process developments that you guys have been able to, and others have been able to, generate and help kind of connect the dots of the real world application. Now, I'm assuming with graphene, it's probably not as, it's more recognized of a lot of the potentials, but because of all the things you're talking about, conduction, flexibility, strength, I mean, all these different things, the potential applications are kind of mind-boggling. Is that a fair assessment?
Yeah, it's mind-boggling, and it's so much fun. I mean, we've got probably 5 or 6 new companies that we're going to launch over the next couple of years. I mean, discoveries that are just amazing. It is so much fun to do this. And when we discover something, we look at it, could this benefit society? And if it does, I mean, we are just filing patents. Just filing patents, and then we write the papers. And what happens is, in this field of entrepreneurial development, success breeds success. And if you've had other companies where people have put in money and they've made money, they want to put more money on you. And even if they don't deeply understand the technology, you've had these successes. So when I go to them and I say, this is a winner, this can make money. Here's what the current state of the art is. Here's what we can do. This is what this means. Sometimes to the business guys, I got to explain it very slowly and gently. And then they start getting it. They speak to a couple of their advisors and they say, okay, let's do it. Let's do it. And the way I do this, I mean, the way I can have the 14 companies that I have and more starting is I don't do anything with them. Is I just start them. So I get founder stock and I teach them the technology. But within 6 months after they've started the company and hiring people, they're out ahead of me anyway. Like on the flash graphene, we're up to a certain scale in our lab. We're going to be doing a kilogram a day in our lab, which that's not much. But the company's way out ahead of us, as they should be. 24/7, they're just thinking about scaling these processes. So they get out ahead of us. And we're doing the academic research and expanding the the application space, but they're really pushing this forward. And so I might serve on a scientific advisory board, but where they can call and ask me questions, but I don't do the hiring, I don't do the firing, I don't do the raising of money. I do very few dog and pony shows when they're going around raising money. Very rarely do I do that. Once in a while, with COVID, it's a little bit easier because I don't have to leave my office. I can just do it all on a Zoom or something. And so I'll help them out that way. But basically, others run the company, and that's how I can do this.
Well, I can tell you this much, as somebody who has been on dog and pony shows for cap raising, I'll just have to say I'm extremely envious of your the individuals associated with your companies are being able to do this. It's walk in, hey gentlemen, yeah, we've had 2 IPOs in the last 6 years, and yeah, here's here's the credibility factors and the potential ROI on this one. It's yeah, very interesting on that one. One other project I had so many that I thought was very, very interesting was and part of the reason I'm bringing this up is I know you've worked directly, some different things you guys have worked on is directly related to cellular inactivity and interactivity. And I believe one of your studies was on reconnecting nerves. I think you did experiments in mice, right? Wasn't that
It was a rat.
It was a rat. Okay, sorry.
Yeah. So what happens? It's really amazing. If you could go on my website jamtour.com and click on the video. I think on the right there you'd see videos of this rat. So the spinal cord was completely cut in two at C5, the base of the neck. We don't do the surgeries in my group, so this was done in a surgical group, and then we prepared a solution of graphene nanoribbons. This is strips of graphene by taking carbon nanotubes and splitting them open to make a ribbon. And what happens is you put it in this gap in the spinal cord now, and you do this. Just by opening it up, so you have these graphene nanoribbons dissolved in a polymer matrix. When you do this and then push together, the shear flow causes the ribbon structures to immediately align in line with the spinal cord. And then you push it back together. And then you sew back the head of the rat to just let the spinal cord refuse. And what happens is normally the neurons will grow. They'll grow from bottom to top and top to bottom, but they usually miss each other like ships in the night, and then they'll never fuse again. But we put in the graphene nanoribbons, and there's billions of them put in there because these are nano-sized. And the neurons love to grow across graphene. We had shown that in many previous experiments because these are conductive entities and they love to grow across this conductive substrate. So they grow across this and they start growing along the ribbons, and the ribbons are bridging this gap. And so all of a sudden the neurons collide. When they collide, they refuse. So the first 2 weeks, the rat is just sitting there and kicking around, sort of like a baby, because its brain needs to remap the connections. It's not the same connection to the right toe anymore. And so the brain is remapping. So we take advantage of the plasticity of the brain, meaning the brain has the ability to correct all of this stuff. And then after 2 weeks, the rat gets up and starts walking around. And it's very much like a baby that's learning. The baby, you first put food in their hand and they stick it in their ear. And then eventually they make the connection. If I bring it up to my mouth, it's better. And the brain just remaps. In a baby, it's just mapping, not remapping, but originally mapping this. It remaps in the rat. And by 3 weeks, the rat is running, scored a 18 out of 21 on a mobility scale. We're scored a 19 out of 21, where 21 is optimal mobility. Scored a 19. It's one of its front paws after 3 weeks was still a little curled up. But yeah, this is so much fun. It's just amazing what's happening, John. I mean, we could spend a whole time talking about this, but I think we need to move on. But yeah, this is what I do for a living. This is what makes me money. The Origin of Life videos cost me money.
That's very true, and I agree. I mean, I could talk to you about this sort of thing all day. It's truly fascinating. Now, let's get back on track. So, in line with the series, there's been a amazing amount of response to each video. We were talking about this, and you were talking about thousands of people are watching this, more people than access papers in their entirety, except for some of your most cited ones. And I know that you've been a little bit too busy to read most of them. So I know Ryan and a couple of us got together and we went through a lot of them for you, compiled quite a few, and you've graciously agreed to respond to a huge chunk of them. So for the audience, if people are watching right now, we're going to be going through a plethora of the comments. So you will definitely want to stay tuned for all of this. You're not going to want to miss it. But before we get into all of that, we're going to dive into a little bit about Dr. Tour's podcast and also just the concepts of science and faith. So you won't want to go away. All right, thanks so much for sticking all the way through. That's the end of part one of my interview with Dr. James Tour. It was kind of interesting to me listening to and looking at the some of the chats, people wanting to know, like, why are we talking about these other things he's doing? Well, I mean, I was having an opportunity to have a conversation with a man of renown, and sorry, haters, but I decided to dive into things of even greater detail and other topics than just origin of life research, even though we get into it in much more detail later on. Now, for everybody that's hanging around, we're going to head on over to the after show. And how that's going to work is Dr. Ryan Hayes, Dr. Carter, and Dr. Gart are going to join me first. And they're going to kind of have a panel discussion. I know they've been collaborating on some different things that they want to discuss, and they're going to address in relation to the Professor Dave videos specifically, not just Dr. Tour's interview, but what was raised by this latest round of attacks from Professor Dave in relation to Dr. Tour. So you want to come over and check that out. Link is pinned in the chat. I'll post it again here inside chat here in just a moment. So they're going to talk for 30 to 45 minutes. And then after that, we'll open up the room and more people can come in. I'm not sure how long the doctors are going to stay, but after that, we can kind of get into much more discussion. So I hope people will come and join, and we'll have a good time over on the other channel. So make sure you look out for the chat. Head on over there right now. It'll be starting in about 4 minutes. We'll get things kicked off. So get ready, folks. It's going to be a fun time. I have no idea how late we'll go tonight, but this should be a very interesting expedition into this topic.